Alright, so corresponding angles postulate can only be used on 1 through 3, which means we're going to use everything else in our memory to prove this, because we're going to prove out our 3 theorems of alternate interior angles theorem, alternate exterior angles theorem, and consecutive interior angles theorem. So, statements, reasons. We have statements. We have reasons. So the first one is A is parallel to B. Line A is parallel to line B. That is given. 1 is congruent to 2. Maybe. But we need to double check. So based on lines being parallel, these are corresponding angles. So step 2, angle 1 is congruent to angle 2 by corresponding angles postulate. Angle 1 and 3 are vertical angles, and as we learned in chapter 2, angles 1 and 3 will always be congruent because of that. So step 3, angle 1 is congruent to angle 3. That's your vertical angle congruence theorem. 1 is congruent to 2, and 1 is congruent to 3. So if I take out this middleman, angle 2 is congruent to angle 3, which is what I need to prove. And the property that I used to do that was the transitive property of congruence. So that's our first proof. We just proved the alternate interior angles theorem. Number 2, we need to state that angle 1 and angle 2 are supplementary. This is roughly about a 6 to 7 step proof. We're going to figure this out. So to start, number 1, A is parallel to B. That's your given. Number 2, so since A is parallel to B, lines A and B, we're looking for some corresponding angles. 3 and 1 correspond, so angle 3 is congruent to angle 1. Order doesn't matter as long as you have congruence symbol. That's the corresponding angle postulate. Once again, it's not the converse because we are not saying that lines are parallel, so it's the postulate. Now I know that angles 3 and 2 are a linear pair. They form a line. They are adjacent, share a common vertex, common side. So step number 3, angle 2 and angle 3 are supplementary. That is the linear pair postulate. Since we say they're supplementary, that just says that they're supplementary, so we'd have to use measures. So step 4, measure of angle 2 plus measure of angle 3 equals 180 degrees. That's using the word supplementary from above, so that's definition of supplementary. Now that I've introduced the ideas of measures, I need to do something with this congruence. When we know angles are congruent, we know their measurements are equal. So step 5 would be measure of angle 3 is equal to measure of angle 1. That's using the definition of congruence. So step 5 would be definition of congruence. Now that the measures are equal, and I have measure of angle 3 in line 4, and I need 1 because I need to get to 1 and 2 being supplementary. So we're going to do some substitution. So step 6, measure of angle 2 plus measure of angle 1 equals 180 degrees. That's step number 6. That's just substitution. Property of equality, because this is an equals, it's an equation, so it's of equality, and you only can use substitution with property of equality. Number 7, since their measurements add up to be 180 degrees, angle 2 and angle 1 are supplementary. Oops, lost my T there. Even though my order switch, I wouldn't take off for that. Since they are stated they're supplementary, I have proven that out, and that's using the definition of supplementary. So, like I said, it was a 7-step proof. I said roughly 8 in class without writing it down. It's 7 steps. That proves that consecutive interior angles are supplementary. Proof number 3. Angles 1 and 3 are vertical angles. Looking at the picture, I got some parallel lines given my given information of A is parallel to B, and I'm going to have to do something with angles 1 and 2. So, left sides, you got step 1, A is parallel to B. This is your statements. This is your reasons. That's your given. Number 2, as I stated, 1 and 3 are vertical angles, so I'm going to say angle 1 is congruent to angle 3. Vertical angle congruence theorem. And 1 and 2 are congruent, and that's by the corresponding angles postulate. One is congruent to 3 and 1 is congruent to 2, so cut out the middleman. Angle 2 is congruent to angle 3. That's the transitive property of congruence. So therefore, I've done my proof line and I've proven that alternate exterior angles are congruent. So that's the first 3 proofs. Yes, the second proof is really in there and in depth, but you're going to use definition of supplementary and definition of congruence many times, so we need to get in the habit of understanding that. On the back side, we got a lot of proofs here. We got 3 proofs again, and you can use whatever you want. You can use any of the transversal angles postulates or theorems, so you can use corresponding angles postulate, alternate interior angles theorem, alternate exterior angles theorem, and consecutive interior angles theorem. What we're going to have to do is prove lines parallel here, so we're going to use a converse. There are multiple ways you can do this, so I'm going to write a little bit smaller, and I'm going to zoom in a little bit. So, the first thing we have is our 2 given information. So, my first proof I'm going to do here is statements, and then reasons. 1 is A is parallel to B, and angle 1 is congruent to angle 2. That's your given information. So looking at that, 1 is congruent to 2. A and B are parallel, so my parallel markings are on these ones based on my given information. So the first way I can do it, I'm going to go 1 and 3 are congruent because of the beautiful corresponding angles postulate that we've been using. So angle 1 is congruent to angle 3, and that's by the corresponding angle postulate. Now, here, since I already know 1 is congruent to 2 and 1 is congruent to 3, I can do the transitive property. So the first step of doing this is 3. Angle 2 is congruent to angle 3, and that's by transitive, which we saw a lot on the first page. Transitive property of congruence. So now that we have that, angles 2 and 3 are alternate exterior angles. So since alternate exterior angles are congruent, therefore lines K and M are parallel. So step 4, K is parallel to M. That would be the alternate exterior angle converse. Now, instead of doing that, here, what I'm going to do is I'm going to talk about the first step. So at number 2, instead of doing transitive, I'm going to use this angle 4. So roughly the same proof. I'm going to copy down the first 2 steps. So 1, A is parallel to B. Angle 1 is congruent to angle 2. This is given. And as we stated, 1 and 3 are on the transversal and they're corresponding. So like I said before, we're just copying it down, but I just want to make sure we understand this. Corresponding angle postulate. And I know I've written these different ways each time. The biggest thing is when you are doing this, I have to know exactly what you're thinking. And my pen, I think, is almost out of ink. So postulate, there we go. Corresponding. So now that 1 and 3 are equal, we're going to use this angle 4. So 3 and 4, angle 3 is congruent to angle 4, and that's the vertical angle congruence theorem. 1 is congruent to 3, and 3 is congruent to 4. So step 4, angle 1 is congruent to angle 4. That's transitive property of congruence. 1 is congruent to 4 and 1 is congruent to 2. Take out that middle man. I'm going to say angle 2 and angle 4 are congruent. So step 5, angle 2 is congruent to angle 4 by the transitive property of congruence again. Now 2 and 4 are corresponding angles on the transversal of B, line K and M, just like we had 2 and 3 being alternate exterior, but now I'm looking at corresponding angles instead. So step 6 would be K is parallel to M, and that would be by the corresponding angles converse. So you can do the same proof in 2 different ways. One is 4 steps, the other is 6 steps. In all honesty, it doesn't matter which way you do it, but the one that makes the most sense to you is what you need to do. So there's the 2 ways that you can do it. Once again, you got a 4 steps or 6 steps proof, but if we said it was 4 steps and you did it in 6 and you had more than one way to do the same proof, do it the way that makes you happy. Alright. We want to get 1 and 2 are supplementary. So based on parallel lines, we have angle 1 and angle 4, angle 2, angle 3. We need to get 1 and 2 being supplementary. So with the parallel lines, we're going to have corresponding angles because we have CD being parallel to each other in our given. These are parallel. And then these ones are parallel. When you have 2 sets of parallel lines in the same pictures, we do use double parallel lines. So parallel markings, if I can remember how to make a triangle instead of trying to make them go different ways. So E and F are parallel to each other, and C and D are parallel to each other based on the given. So that means I got some corresponding angles. I have some wonderful corresponding angles here, and then I have some supplementary going on. So with 2 and 3 being equal, and 1 and 4 being equal, and 3 and 4 being a linear pair or supplementary, we're going to have to do some measurement of angles and do some congruence things. So I'm going to be doubling up on some of my reasons. Technically, we're looking at a roughly 8 to 9 step proof. But what I'm going to do is I'm going to cut this video short, and I'm going to end it here, and then I'll come back and start with this proof, and then finish up. That will be in part 2.